Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdi Ali Abdullahi. I will be taking you through chemistry classes, preferably metals. Today we are discussing about metals, and hopefully if we get time we shall finish with you the remaining topics, that is radioactivity, electrochemistry, and the other topics. So today let's start our lesson. It is about metals. And when we are discussing about metals, we need to know first, the student is supposed to know what is an ore, what an ore is. Then by the end of this topic also, you have to know the chief ore of different elements. There's a difference between an ore and a chief ore. Chief ore we're discussing about here, the main ore that the element is extracted from. Then we also need to discuss about the general methods of extraction. The general methods of extraction. Here we're talking about the different methods that an element can be extracted from. Here mainly talking about two main methods, that is electrolysis. An element can be extracted by either electrolysis, electrolytic method, and we can be using also by reduction method. This method we use those elements or those metals which are highly reactive. While this one, we use the less reactive element. We use this method called reduction method. Reduction method, we're talking about those method that is used by a certain reducing agent like carbon. So basically when we're discussing about iron in our next lesson, we normally use carbon as a reducing agent. So it's a reduction method that we shall go into use. Then in each and every element we need to discuss about the physical and the chemical properties of each and every element. Physical and chemical properties of elements, and finally their uses, because these elements have got uses. So without wasting a lot of time, let's directly go to today's topic. Metal. So we need to know what an ore is. An ore is a compound in which metals are extracted from. For example, sodium. If you want to extract sodium metal, you have to have an ore. It's a substance or a compound in which the metals are extracted from. For example, zinc. So it has got an ore, that is zinc blende, right? So, but there is something called chief ore. So it's a different chief ore. The chief ore is an ore in which metals are obtained on a large scale. What do we mean by here large scale? We mean in large quantities. So an ore, a chief ore, basically is an ore which a metal is obtained on a large scale. Large scale, we said, in large quantities. So we discuss the chief ore as a next topic, chief ores of metals. And the first one is sodium. So here you have the metals, the ore, and then their formula. You have to know each and every metal, the chief ore or the ore that is extracted from, and even their formula. So to start with, sodium sodium metal. The ore is called rock metal. Rock salt. Rock salt, I hope you understand, those of you who have prepared hydrogen sulfide gas, is solid sodium chloride. Solid sodium chloride. So that is what's the ore that this element is extracted from. The formula is just the basic sodium chloride here. Let's move to next one. The next metal that we shall be discussing in few time is aluminium. Aluminium. So aluminium has got different ores, but there is a one which is we are calling chief ore. That is the main ore. So that one is called bauxite. And the bauxite here, it has got other ores. We have something called mica. We have something called corundum. But what we are considering is the bauxite. So basically what is being asked in the exams are the chief ore of elements. So we shall be using, this is the chief ore of the element. This is the chief ore of aluminium. So what do you mean by bauxite? Now, bauxite, the formula is just basically aluminium oxide, which is hydrated. So if you are not getting a bauxite, you are just talking about aluminium oxide, which is hydrated. Aluminium oxide, which is hydrated. We move to the next one. The next one is copper. These are the most commonly asked questions. Copper. So copper, we have got also copper pyrite as a chief ore, copper pyrite. And then we have also something called cuprite. So how do you write the formula of copper pyrite? This is the formula of copper pyrite. And the cuprite, we're talking about copper 1 oxide. We're talking about copper 1 oxide. We go to the next one. The next metal that we're talking about is iron. Iron has got several ores. Iron has got several ores. Iron has got several ores, and the first one, something called hematite. The second one is siderite. And then the third one is magnetite. So what do you mean by hematite? Hematite means iron 3 oxide. So hematite is just same as iron 3 oxide. Siderite is iron 2 carbonate. Iron 2 carbonate. And then magnetite is something that we have learned in Form 1. Yes. What is that name? Or what is that formula? It is triiron tetraoxide. Triiron tetraoxide. But in an exam, if you are asked the chief ore of iron, just say hematite. This one will be enough. So basically we use these two major, but hematite will be enough. So we shall be discussing about iron when we reach there. And the chief ore that we shall be using is iron 3 oxide. The fifth one is zinc. Zinc, fifth metal that we shall be discussing later on is zinc. And the zinc has got two ores, zinc blende, and then we have calamine. Now, for the zinc blende is zinc sulfide. The formula is zinc sulfide. Zinc sulfide is what we are calling zinc blende. And then calamine is just zinc carbonate. Yes? So these are just very familiar formulas that we have discussed in Form 2. So these are the two major ores that we shall be using. So we shall be using both zinc sulfide and zinc carbonate. Zinc carbonate and zinc sulfide. Then the last one is something called lead metal. Lead metal. Lead metal here, the chief ore is called galena. And galena is just same as lead sulfide. Lead sulfide. We have got others, but the most important one that we shall be considering here is galena. We have something called chrysite. Yes. We have something called anglesite. These ones mean lead sulfate. Chrysite means lead carbonate. But what we shall be considering is the lead sulfide. So having said that, these are the chief ore that the elements are extracted from. So now let's go to the next subtopic, which is how do the general methods of extracting metals. Before you extract a metal, you need to first concentrate the ore. And in the process of concentrating, with certain procedures that we shall look. So the next subtopic is general methods of extraction. The specific method, but the general one, which is common to almost every element or every metal, are these ones here. General methods of extraction. General methods of extraction. And the first one, the process, so let's write the note, the process of concentrating the ore. So we said before you purify a metal, you need to first concentrate it. So the process of concentrating a metal or an ore includes the following. So first, what you are supposed to do, you remove any magnetic material using a magnet. What do we mean by magnetic material? These are materials which are attracted by a magnet. These are materials which are attracted by a magnet. So you remove any magnetic material that surrounds that place. Number two, what do? You dissolving the mineral in a suitable solvent. Then number three, washing water. You wash it with water. Washing water to remove the earthy matter. You understand what earthy matter is here, right? And then lastly, most of the metals we use a certain process called froth flotation. And this is basically where we shall be discussing more. Yeah? So froth flotation, this is one of the method. This is one of the method that is used in purification of metals. What do you mean by froth flotation? Froth flotation, we're discussing about the ore is ground into a fine powder. Into a fine powder. So you crush it or you ground it into a fine powder, the ore. Yeah, that is the chief ore that you want to extract, the ore that you want to use to extract a certain metal. So we are telling you it's grounded or it's ground into a fine powder, into a fine powder. What do you do next? Yes, it is then mixed with a special oil such as pine oil, which is used as a frothing agent, So you mix it with a special oil. Okay. What do you do now? Next. So we said the ore is grounded into a fine powder. It is then mixed with a special oil such as pine oil. Yes. Then a froth. Yes. I hope you understand what a froth is. 2 layers, yeah? Like for example, if you mixed a certain ore with a special oil, it will form a froth. So a froth rich in mineral is formed on top, while the impurities, you are avoiding the impurities, yeah? The impurities sink to the bottom. So this is one of the most important process of purifying metals before they are extracted. So froth flotation is the most commonly used. We said the ore is ground into fine powder, then it is mixed with a special oil, such as a pine oil, then a certain froth is formed on top, while the impurities will sink to the bottom. So froth flotation, like metals like copper, yes, zinc, then lead. This is a process that we normally use. Froth flotation, the most commonly used way of purifying metals. Is the most commonly used in purifying metals. Now, let's go to the next one. Now, the method of extracting So, the method of extracting a metal depends on the metal's reactivity. And that's what I said when I was starting, yeah? What did we say? We said more reactive metals, such as sodium, for instance, are obtained, yes? So less reactive element, lastly, less reactive elements, less reactive element, such as iron, are obtained by reduction method. By reduction method. What do you mean by reduction method? I discussed already. For instance, we said iron 3 oxide, sorry. Iron 3 oxide is the chief ore of iron. For instance, this one we shall see it later. So when we are extracting an iron metal, we use this method called reduction method. And reduction method, we said we use a certain reducing agent. So this reducing agent will reduce the carbon, will reduce iron 3 oxide into iron metal. Yes, and then the carbon itself now will oxidize into carbon 4 oxide gas. So yes, so you can see this one is reduced, this one is oxidized. So there are those metals which use reduction method, like copper. For instance, copper uses both. It can use the electrolytic method, because we shall be using in our electrochemistry lesson, we have seen copper 2 sulfate, copper 2 sulfate as an electrolyte. So we can use that method. We also use, since they are very low reactive elements, we can use reduction method. So we shall start with sodium metal. So we're discussing about sodium metal. Sodium metal is obtained by a down process. Where molten sodium chloride is electrolyzed. Why do we use molten sodium chloride? Because we are talking about the chief ore of the element, the chief ore of sodium. We said sodium chloride. So this is a down cell. Have a look at it, this picture, this diagram. Sodium chloride is the chief ore. So it is in sodium chloride in. So we are basically talking about we use a down process. This down process now is a down cell. So down cell consists of ion shell Yes. So, as you can see here, the outer here is what we are talking about, the shell, the ion shell, which is made up of heat bricks. Why do we use the heat bricks? Because to maintain the high temperature, So the heat resistant wall, which is outside, that is covering here, this down cell, the heat resistant wall is to maintain the high temperature so that the electrolyte does not crystallizes. So basically, the heat resistant wall, is used to maintain the heat resistant wall that is covering the outer layer that is made up of the heat bricks is used to maintain the high temperature, the high temperature, the high temperature, so that the electrolyte, remember our electrolyte is molten sodium chloride, so that the electrolyte does not crystallizes, does not crystallizes. So we have talked about sodium chloride down cell. This is a down cell, yeah? So what are we talking about? The outer region here is made up of ion shell. The reason that it's made up of ion shell is because this wall is used to maintain the high temperature so that the electrolyte does not crystallizes. So at the center, this is the center, yeah? This is the center. We have a carbon anode. So let's write at the center of the cell, at the center, at the center, at the center of the cell, at the center of the cell is carbon anode, which is surrounded by a steel cathode. Since this is high reactive element, the process that we are using is an electrolytic method. And for you to get an electrolysis, for you to discuss about electrolysis, we said you must have a cathode and an anode. And you must also have an electrolyte. So our electrolyte, we have already discussed, it is molten sodium chloride. Our electrolyte is molten sodium chloride. Then we must have electrodes. And the electrodes is the carbon anode, which is at the center here, yes, surrounded by a circular steel cathode. This is the cathode, yes. These are the two cathodes. And then at the center, we have carbon anode. The reason why we normally choose carbon is because carbon is an inert electrode. Carbon is an inert electrode. Carbon is an inert electrode. So let's go to the next one. In this process, before you start the extraction, normally calcium chloride is added. Yes, you can see here we have written molten sodium chloride plus calcium chloride. So calcium chloride is added. Why? Calcium chloride is added to the sodium chloride, to reduce the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius. From 800 degrees Celsius to 600 degrees Celsius. So in this process, sodium chloride, this is the electrolyte that we want to use, the O, our chief O. When it enters here now into the down cell, we normally add calcium chloride. What is the purpose of adding calcium chloride? It is to reduce the melting point of sodium chloride, or to reduce or to lower the melting point of sodium chloride from 800 degrees to 600 degrees. So 800 degrees, that is too high, yeah? So for you to reduce, we normally add calcium chloride. We normally add calcium chloride. Now this one is economical. This is economical. This is economical since it saves electricity. Since it saves electricity during heating. So that is the purpose of adding calcium chloride into the mixture, into our electrolyte. So let's come to the electrolysis, the process now. We said we add calcium chloride. Yes. So during electrolysis, this is a major, yes, this is the most important part. During electrolysis, what happens? During electrolysis, sodium metal is formed. Sodium metal is formed at the cathode. Whereas chlorine gas yes. So during electrolysis, what happened? Sodium metal, you can see sodium metal that you have been looking, is formed at the cathode. And we shall explain how. And then chlorine gas is formed at the anode. So this is now chlorine gas out. How now? How does this happen? Sodium chloride, which is a molten, contains two ions, sodium ion and a chloride ion. And then we have also electrolysis of water, hydrogen ion and hydroxyl ion. In our electrochemistry lesson, basically an anode is a positively charged electrode. So what will happen? Chloride ion and hydroxide ion will migrate to the anode. They will come to the anode. They will migrate to the anode. But which one is discharged? For you to get the preferential discharge of ions, there's factors to consider. And the first one was position in the electrochemical series. Number 2 is something called concentration of the ion. So basically we're talking about concentration of the ion. And then number 3, we talked about nature of the electrode. Those are the factors that we consider. For our case now, let us confine ourselves into the concentration. This is concentrated sodium chloride. So the ion which is more concentrated is the one that is discharged. And between hydroxide ion and the chloride ion, when they migrate it to the anode, chloride ion is discharged. So we will choose chloride ion over hydroxide ion because this one is more concentrated. And in our anode reaction, chloride ion, if it is discharged, chloride ion will lose 2 electrons and it will form chlorine gas and 2 electrons are lost. We're talking about lost, and then, yes, so basically we don't write chloride ion minus 2 electrons, this chlorine gas, this is how it's supposed to be. But when you take this negative to the other side, now this is where we have in the plus, so we don't write negative here. So it is supposed to be chloride ion losing 2 electrons and then forming chlorine gas at the anode. And then when you balance this equation, here we have 2, yes, that is it. So this is the most importantly asked question, yeah? Write the equation at the anode. At the anode, we have 2 ions, hydroxide and chloride. Yes. Basically, this one you have already learned in electrochemistry, yeah? But sodium chloride ion is the ion that is basically discharged. So chloride ion, it will lose 2 electrons, and you get chlorine gas, and 2 electrons are lost. Now let's go to the cathode. The cathode now, the sodium ion is discharged. Sodium ion will gain 2 electrons, and it will form sodium ion molten. Sodium ion molten, or sodium metal. Sodium metal. So this is aqueous, and when you balance, it is 2, 2. So at the cathode, we have sodium metal that is deposited. At the anode, we have chlorine gas. We have chlorine gas. We have chlorine gas. So basically, in electrolysis, we discuss about non-binary electrolyte, but this one is more of binary. Binary electrolyte is an electrolyte which consists of 2 ions. 2 ions. And we have sodium ion and the chloride ion. So the chloride ion will migrate to the anode, yes, and then when it migrates to the anode, it will lose 2 electrons and it will form chlorine gas. It will form chlorine gas. And then at the cathode, we have sodium ion that will migrate there, and then when it gains the 2 electrons that has been lost here, it will form sodium metal, which is a molten, which is a molten, which is a molten, which is a molten. So now basically we have seen how sodium metal is being obtained here. Sodium metal, yes. So at the anode, what is being deposited here is chlorine gas. So chlorine gas is out there. Then at the anode, we have sodium molten. We have sodium molten, molten sodium. That is what we have been looking for. That's what we have been looking for. And next one, now the last one, steel diaphragm. Steel diaphragm is suspended steel diaphragm is suspended between the electrodes. The electrodes, I mean here, the steel diaphragm is here. This dots here is what we're talking about, steel diaphragm. Steel diaphragm, yeah? So the steel diaphragm is suspended between the electrode, that is the cathode, and the anode. Why? Steel diaphragm is suspended between the electrode to prevent sodium recombining with chlorine. So to prevent recombination of this sodium molten and the chlorine gas that has already been deposited at the anode, to prevent recombining and so that they form sodium chloride, we normally suspend a steel diaphragm. So this is a commonly asked question also. Steel diaphragm. What is the importance of steel diaphragm? Steel diaphragm is suspended between the electrode to prevent sodium and chlorine from recombining. Sodium and chlorine from recombining. Then next, molten sodium. So we said the steel diaphragm is suspended between the two electrodes to prevent sodium and chlorine from recombining. So what we have here is now chlorine gas that is out here, and then sodium molten at the cathode. So we are saying the last one, molten sodium that has already been deposited at the cathode is less dense than molten sodium chloride. And therefore, it rises to the top where it is periodically removed. So sodium and the molten sodium chloride. This molten sodium is less dense, so it will rises to the top where it is periodically removed, and then we have our molten sodium. Chlorine gas is not allowed into the environment because chlorine gas is poisonous gas and hazardous to the environment.